In today's lesson, we're going to go in the opposite direction of what we did yesterday. We're going to convert from standard notation to scientific notation. And you might remember from yesterday, they started with some problems that had a decimal times 10 to a power. So we may have had something like this. They may have given us something like 2.8 times 10 to the negative 6 and 3.05 times 10 to the fifth, and ask us to rewrite those as numbers in standard notation. And remember from yesterday, we said that if we have a big number, then we will have a positive exponent. And if we have a small number, we will have a negative exponent. So if you look at these two numbers, this one has a negative exponent, so that would be considered a small number. This one has a positive exponent, so it would be considered a large number. If they are negative exponents, remember we moved the decimal left this many places, whatever the exponent is. And if it was a large number, we moved the decimal to the right this many places. So for 2.8 times 10 to the negative 6, if they ask us to rewrite that in standard form, we would rewrite the 2.8, and then we would take that decimal and we would move it 6 places to the left because it's a negative number. So 6 places to the left would be 1, 2, 3, 4, 5, 6, and the decimal would now be here. In every one of those loops, I'm going to put a 0. So for that example, this is what we would end up with, 0.000028. For this one, I'm going to rewrite the 3.05, and I'm going to move that decimal 5 places to the right because the positive 5 tells me this is supposed to be a big number. 1, 2, 3, 4, 5. Everywhere that I have a loop, I'm going to put in a 0. So my new number here would be 305,000. In this section, we're going to go backwards. Today, they're going to be giving you numbers in standard notation and ask you to convert those to scientific notation. So, if your number is big, in other words, it has a positive exponent, then we can associate that with a large number. When we do this, we're going to do the opposite of what we did yesterday. Yesterday, if it was a big number in scientific notation, we moved the decimal to the right that many places. Today, since it's already in standard notation, we're going to move the decimal to the left until our number is between 1 and 9.9. So what we have to do, our decimal in any number that doesn't have any decimals in it is all the way to the right. So that's where my decimal is if there's no decimal in the problem that we can see. So this is where my decimal is at the very end of the number if we don't have any decimals in there that we can see. And then we need to move this decimal and count how many times we're moving it until our number, or our new number, is between 1 and 9.99. In other words, there's only going to be one number to the left of the decimal. So we want one number, this 2, to be the only number to the left of the decimal. So when I do this, I'm going to count as I move my decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved my decimal 10 places. So when I rewrite this number, it's going to be a 2.8, and we multiply that 2.8 times 10, and that 10 will be to the power of the number of times we moved the decimal. And remember, when we counted, we moved it 10 places to the left. So we moved it 10 places. Now, we need to decide, is this going to be a positive number or a negative number? A negative exponent or a positive exponent? Well, was this number to begin with really big or really small? It was really big. So that's going to be a positive 10. In this one, notice this is a very small number. So when it's a very small number, we have to have a negative exponent. We will move the decimal to the right, again, until our number is between 1 and 9.9. So we only want one number to the left of the new decimal place. This would be the number that I want to the left of my decimal place, my 5. So I'm going to go up here, take my decimal, and move it until it's to the right of that 5. 1, 2, 3, 4, 5. My decimal place is now here. So when I rewrite this number, it's going to be 5.23. I'm going to make that times 10, and it's going to be times 10 to the power that I moved it. I moved it 1, 2, 3, 4, 5 places. My power will be 5. And then I need to determine, is that power a 5 or is it a negative 5? It was a really small number, so that we associate that with a negative, so that's going to be a negative 5. So it's 5.23 times 10 to the negative 5th. So in Delta Math, your examples are going to look like this. Write the number 9,700,000 in scientific notation. Well, that number has a decimal at the end. That's where my decimal would be. It is a very big number. It's going to be a positive exponent. And notice here, they have already started your scientific notation for you. All you have to do is fill in the blank. So I'm going to move this until I get a number between 1 and 9.9. So I'm going to move it until there's only one number to the left of the decimal. 1, 2, 3, 4, 5, 6 places. So the number I would type in here would be 9.7. And then it moved 6 places to the left. It's a 6. So I've got a 6 in here. Since this was a big number, that 6 is positive. And then I would hit submit and look at my answer. This one is a very small number. I need to move my decimal until my number is between 1 and 9.9 so that there's only one number to the left of the decimal. I would move it 1, 2, 3 places. So in here, my answer will be a 3.3. I moved my decimal 3 places. It was a very small number, so my 3 needs to be negative. So in Delta Math, I would type all that in my blank. So I'm going to go to Delta Math now, and we're going to look at a couple examples in there to make sure you understand what you're doing. So here I am in Delta Math. I'm going to rewrite that number on a piece of paper. 0.00002. I need to move my decimal until I only have one number to the left of the decimal. So I'm going to move it until I get right here at the 2. When I do that, I have 1, 2, 3, 4, 5 places that I've moved my decimal. When I type it in, I can put a 2.0, or you could just put a 2. They mean the same thing. And I moved it to the left 5 places. So that will be a negative 5. Because this is a very small number, we need a negative exponent. I submit it. I hit yes. We got it right. This problem is considered a large number. So we're going to do 6,600. I'm going to write it on a piece of paper. My decimal is understood to be right here at the end. I move my decimal until I get a number between 1 and 9.9. I'm going to move it 1, 2, 3 spaces. When I move it 3 spaces, my new number is a 6.6 times 10, and I moved it 3 places. It was a big number, so it's a positive 3. We submit. We got it right. And that's all you need to know how to do. So go through now and do the practice on Delta Math and see how you do.